Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 3 for this week. And periodically we talk about ensembles and percentiles and all that type of thing. And I thought it might be worth it to go into a bit more detail so it makes a little bit more sense. Basically, the whole purpose of ensembles, before we even get into this, is the fact that if you simply take a look at one computer model forecast, that's what's called a deterministic forecast, in the sense that if that's all you're looking at, that model is trying to determine what the weather is going to be. Well, we cannot analyze the atmosphere perfectly. If you think about it, it's a big globe, a big atmosphere, and even if we have the highest resolution models available, we're not able to see every single little detail down to the square inch all around the globe. So there's inherent error in the analysis, okay? And errors like that tend to grow with time. And so what we want to try to do using ensembles is to see how sensitive the atmosphere is to those small errors at the beginning. Sometimes it's not, and sometimes you change the initial conditions just a little bit to 30 different extents, and you run them all the models out, and they're very similar 3 or 4 days out. And so that tells you that the atmosphere is not sensitive to those small errors and that you have a high confidence forecast. If, on the other hand, they're all over the place, like a finger painting exercise, then that means that the atmosphere is sensitive to those small errors at the beginning, and it's a low confidence forecast. So we always want to take a look at the range of the ensembles and where that middle 50% is and all that kind of stuff. So let's get into it here, and we're going to take a look specifically at the ensemble temperature forecast for actually this should be 1 p.m. I'm still thinking daylight saving time. I got to get out of this mode. But the temperature at 1 p.m. on Tuesday, and these are the 30 different ensemble members, and you can see that, if you look at it here, here's a 55, a 56, a 60, then a 42, and then a bunch of 60s here, and so forth. So what we want to try to do is see, is this data distributed in a normal fashion? And a normal fashion would be your classic bell curve, where it starts off up here, peaks in the middle, and then it comes down on the other side. So, and if you take a look at the distribution here, 4 of the ensemble members are in the 40s, 13 in the 50s, and 13 are in the 60s. So this is the bell curve, and I know you're sitting there looking at that saying, that's not a very pretty bell curve, and you're right. But the reason it looks like that is that this data is not distributed normally, okay? It's top heavy on the right end and low heavy, if you will, on the low end. There are very few members that have temperatures in the 40s. So we can actually analyze this by taking a look at the lowest 25%. And you can see that that's a fairly narrow band there, okay? Like if you take a look at this whole range of temperature from 39 to 68, that this is a fairly narrow area. So these are what we call outliers on the low end, okay? Then the middle 50% is right in here, and you can see that area is pretty fat, and that ranges all the way from 46 to 61, okay? But it's still a lot fatter than that lowest 25. And then the upper 75% ranges from about 61 to 68. So those are outliers, if you will, on the high end. But the fact that this area, this outlier area, is wider than this one here indicates that the cold end of the spectrum, there are far less ensemble members that are tilting really cold than there are tilting very, very warm. So with that in mind, we would certainly want to skew our forecast toward the higher end of this range, okay, as opposed to those 3 or 4 outliers that have us in the 40s. And if you can actually compute probabilities here. There are 30 ensemble members, and there's only 4 that are in the 40s. So the probability of the temperature at 1 o'clock Tuesday being in the 40s is just a little over 13%. But the probability of it being in the 50s is 43%, and the same with the probability of it being in the 60s. Now, our forecast, or my forecast at this point in time, is 59. I think the coldest air, because it's going to be one of these cold air damming scenarios, is going to be back in the western Piedmont and the foothills like it normally is, and that would include areas like Greensboro, Winston-Salem, Charlotte, Hickory. Those areas could very well stay in the 40s. And then there's probably going to be an area down toward the coast that's in the 70s. and then it's going to gradually cool as you head westward across the coastal plain and the Piedmont and into the foothills. And so 59 is my best educated guess as to where we're going to be in that transition zone. But a lot of times that temperature gradient is so tight that if you are off 25 miles either way on where it sets up, it can make a big difference on the way temperatures turn out. I remember when I first got to Raleigh, the first winter, or it may have been the fall, that the temperature at the RDU airport was 42, and they had zero visibility in fog and had to close the airport. In North Raleigh, just 10 miles as the crow flies away, it was 55, and once you got over towards Smithfield and Rocky Mount, it was in the mid-60s. So you can get these tremendous ranges in temperature over relatively short distances in these cold air damming scenarios. So this is just the way that we look at the Ensemble data. Gives us an idea as to who the outliers are and what is more likely from a probabilistic standpoint, and that's really what we're trying to hone in on. All right, folks, that's it for now. That's bonus weather video number 3 for this week. Hope you have a great weekend coming up and enjoy all the sunshine, and we'll be back with you again on Monday. So take care, and we'll talk to you soon.